afternoon, everyone. My name is Don Parkinson, and I'm a consultation specialist with Atkins Realis. Today, we are continuing our series of live stream topics as our project moves through consultation round 2 of the environmental assessment phase. The topics we are covering parallel our project activities or are of community importance, so we hope these will help our viewers and listeners better understand the project and provide input along the way. With me today and in many other shows going forward is Jennifer Ashwazage Pereira, my colleague and an Indigenous engagement and traditional knowledge specialist at Atkins Realis. Jennifer is a member of Henvey Inlet First Nation, located on the French River south of Sudbury, and works with me on our projects across Canada. So let's get started. Hi, Jen. How are you this week?
I am fantastic. And yourself?
Yeah, pretty good. It's Monday, right? I'm not worn down yet, right? We're
Not yet.
higher
You're
energy on
fresh.
Mondays, aren't we, Jen? We're fresh, yeah, yeah. Watch us wilt as the week goes on. So today we're going to discuss a topic that is always of interest to community members. The topic is water crossings, and it's centered around helping to explain the different types of structures, both bridges and culverts, that will be part of the Webequie Supply Road project. We think it's important to discuss these topics and share that discussion with our viewers and listeners. So let's get started, Jen. And
Okay.
as we always do, right? We like to get everybody up to the same level in terms of reminding them about our project. Um, so that's gonna be what we do first, and then we're going to talk about all the watercourse crossings that are part of the Webequie Supply Road project. We're going to talk about bridges, and then we're going to talk about culverts, and then we're going to talk about how you can talk to us after that. So
hmm
let's move now to the project location. Just to remind everyone where we are located here, Webequie First Nation is located about 200 to 250 kilometers from both James Bay and Hudson Bay, and the road itself is runs from Webequie Airport down to the McFalls Lake area, which is in what's called the Ring of Fire um, mineral rich area. And just let's maybe before we describe the actual project, let's talk a little bit about the purpose of the Webequie Supply Road project. And this project's been in the works for quite a while. And the main purposes of the road are to, first of all, move materials, supplies, and people from the Webequie Airport to the McFalls Lake area. Secondly, to provide employment and economic development opportunities to Webequie First Nation, but also allowing them to preserve their language and culture and continue to live in their communities while they work on and take advantage of economic development opportunities in the region. And then finally, if we can change the slide to the purpose of Webequie Supply Road, there we are. And then finally, to provide experience and training opportunities for youth, and in doing so, help encourage them to get additional skills either through post-secondary education or other forms of training as well. In terms of the actual project itself, the road is planned to be 107 kilometers long, extending again from Webequie Airport, which is on the reserved lands, um, east, and then southeast to the McFalls Lake area, east of the Mukatai River. 17 of the 107 kilometers actually sit on reserve lands. Uh, the actual corridor that we are working with right now, which is the preferred corridor, is 2 kilometers in width. So that is the sort of the band of land that we're working with, the ribbon of land that we're working with that runs from Webequie Airport to McFalls Lake area. It's 2 kilometers wide, so the road could sit somewhere within that 2 kilometer wide band or ribbon. And then the
So there's
actual
some wiggle
cleared
room
area,
there.
there's some wiggle room. That's right, Jen, and that's the idea behind it, right? Is to be able to have some flexibility because sometimes you learn about things. They could be sensitive areas that we didn't know about before, or traditionally significant areas that we didn't know about before, and that allows you the space, the land, to shift the route around a little bit, so to adjust the route. So the actual cleared area would be 35 meters in width. In terms of other aspects of the project, there will be 3 major water body crossings. The first one being of Winnisk Lake, and then the next one to the southeast being Winniskis's Channel, which is about 30 to 50 meters wide, and then finally the Mukatai River crossing, which is again about 30 to 50 meters wide, and that's at the extreme east end of the project. Um, as I always say, an all-season road project is not just the road, but it's the other infrastructure elements that are associated with it. Some of them are temporary, some of them are permanent. Um, you know, there are both temporary and permanent aggregate pit and rock quarry areas where you get the material to build and maintain the road with. And then at those quarries, you would have equipment for processing or crushing the rock to get it to the right size to use for the different purposes for road building. And then, in terms of other infrastructure, you have a quarry and a pit, but you need to be able to get to that from the main road. So you need access roads, and those access roads may have to cross water courses as well, streams and rivers, and so you might need bridges or at least culverts to cross those water bodies as well. And then there are construction camps. So the construction camps would be temporary, and they typically accommodate the construction crews. Um, they would also provide, they have their own infrastructure associated with them, such as not only the camp houses, but like a wastewater treatment plant or a water storage, drinking water storage tanks, things like that. And then, of course, there are other permanent facilities, that those being, operations and maintenance offices, places where equipment that's used to maintain and materials used to maintain the road are stored. And then finally, during construction, you would have temporary storage and laydown yards where equipment and materials would be stored. Those are typically associated or together with the construction camps. And again, these are temporary. So those areas that are temporary would have to be restored back to according to the specifications that are provided as part of the restoration plans. So, with that, let's move on and talk about the Webequie Supply Road
Watercourse
watercourse
crossings.
crossings, Jen.
Mm-hmm.
So, there are
25.
26 of these, and 25 water course and one water body. Technicality, Winnisk
Okay.
Lake. That's a lake, right? So all the other ones are streams
Yes.
and rivers. Then we got the big one, which is the lake. So coming off the island, you have a big crossing, like I said, 200 to 250 meters wide. And then from there, there's a couple of larger crossings. Winniskis's Channel, Mukatai River, but a lot of the other ones are smaller ones that would only require uh, culverts, different types of culverts, and we'll get into different culverts as well a little bit later on. So um, we're looking to have bridges at over all the major crossings, which is 3, but there may be a couple of other crossings that are big enough to require bridges as well, and then culverts at the remaining ones. But as you know, Jen, there's a lot of factors involved in
Yes,
determining what type of structure, what size of structure at the different water crossings, right? Like you can't do a culvert pipe over a 250-meter wide gap.
that's
Can't do
right.
that. It's too
There's
big. So
a lot of considering
you've got to
factors
bridge that,
here.
right?
Hmm.
Yes. So there's things, and one of the factors is what you call constructability and remoteness of location. So, this is always an important thing in all kinds of construction is how easy is it to build, right? So you can you can design something, but again, in the end, you have to build it. So the idea is to try to design something so that it's relatively easy to build. And when you're talking about building in areas like this, which are very remote, which are very far away from major centers, you need to consider this and try and simplify the construction, I think, as much as possible without
And make sure
compromising
you
the
have
like the
everything.
quality of the work. Yeah, don't forget anything because it takes a long time to get there. You're right. You're right, Jed. That's a great point. That's a great point. So the idea is, simplify design, um, ensure that it's possible, right, to bring, for example, bridge girders of a certain length up on flatbed trucks during the winter, right? Figure out, you have to come up with different ways of making sure it's feasible, right, to get the materials up there, let alone work with them, right? So when you're building in areas like this, there's a lot other factors involved than maybe if you were building something in the south where you have really good transportation corridors and everything's efficient, far more efficient, and it's easy to get materials and it doesn't take long, and so that's a big factor. And then
And
we have
different
maintenance
land,
and
different
life
kind of land.
and different land that you're traveling over and building on, right? Yeah, absolutely.
Hmm.
Especially when we get into talking about the muskeg, right, Jen?
Exactly.
'Cause that's a complicated. It's a much different land type. You don't see muskeg in the south, and so it presents a lot of challenges for on the construction side. So another factor is maintenance and life cycle of the structure type, right? Again, because these structures are so far away, and it takes so long and it's expensive to get materials there, and you've got to keep that in mind, right? And try to build them so that they'll last. Um, and also, when you build structures like this and they're in climates like the climates up there where it gets very cold, right? You can go from very cold
Hmm.
to very hot depending on the time of year, and so the materials that you use in those structures and the way you maintain them has to adapt to that kind of environment, right? So that's a big that's a big factor. Um, Another factor is what we call hydrology. So when we talk about hydrology, we're talking about surface water behavior. So how water behaves as it moves across the surface of the land and the earth in general. And so we need to understand this. You use that information to understand what sizes of, for example, culverts to use, right? So there's a lot of work
Hmm.
that's done on the engineering side in advance by water resource um, engineers who do modeling and look at scenarios, different scenarios. Whether it's 100-year storm scenario, um, and then they come up with a design that they feel will be able to withstand those extreme kind of scenarios. And that kind of stuff, as you know, Jen, is getting trickier and trickier to do, right? Because you've got climate change and you're getting more frequent um, storms, more frequent bad storms too. You're getting more like those things that we used to call 1 in 100 years are happening a lot more often. So the engineers build in a factor of safety to try to account for that. Because of course no engineer wants to design these roads and then have these roads built and have them wash away, right? So
That's
there's
right.
a lot of thought put into this, and hydrology is a big issue, a big factor to be
Mm-hmm.
considered. And then of course there's the environmental side, right, Jen? Like there's the physical and biological characteristics at the water crossing, right? Like fish and fish habitat, right? What are the fisheries there? Is it a spawning site? You don't want to really cross at a spawning site you don't want to do that. So, I mean, it could be the types of soil that are at the crossing site, because that
Yeah,
can
because you
determine,
have to
like,
be
if you're building a
mindful of
bridge, right?
erosion.
Yeah, absolutely, right. And if you're doing foundations for bridges and things like that, you need to understand the soil. Is it good soil to work with, or will it take a lot of extra engineering to get it into the condition where you could actually put a bridge there? There's a lot of considerations. Maybe the fish and fish habitat sensitivity is very high. Maybe it's a sturgeon spawning area or an area where sturgeon are found, like protected species like that. So you've got and a lot of that stuff can be controlled for, I think, just by trying to position the water course in certain areas, right, where that
Mm-hmm.
wouldn't occur because those physical conditions don't exist, right? So some of that work can be avoided just by making sure that the crossing isn't at a place where certain characteristics are, where so, and then the other factor is the fact that people use many of these rivers, right? So
Right.
if you're
So
going to
boat
put in a bridge,
traffic,
it can't be too low. Yeah, boat traffic.
or even a
So,
culvert,
that's something to, yes, absolutely,
because in our
right? Like,
area, our leadership asked for larger culverts to be able to accommodate boats going through some specific areas to get through to Pickerel River or French River.
that's a great point, Jen, right? Like it applies probably more to culverts than it does to bridges because usually the bridges are high enough to accommodate the boats that, community members would typically be using, right? But
Mm-hmm.
culverts might not be, so, when that's why it's important to work with community members and make sure you explain where the crossings would be and see if there would be any issues for them, right? In terms of being able to navigate through or under the road, right?
Right.
So that's a big one. How navigable. If these are waterways that are used by community members, then if you're putting in a culvert, make it big enough to allow community members to get through. So let's move on to bridges now, Jen.
All right.
And
There's going to be a few
like
different styles of bridges, I understand.
yeah, there will be, and we've got some pictures a little bit later on to show everyone. Um, So there's 5 crossings where bridges have been identified. I gave you 3 of them. The other 2, I'll have to double check what the locations are for those, but they obviously meet the criteria for having to use a bridge because at a certain point, excuse me, you can't use culverts anymore, right? Because you're crossing
Right.
too wide a gap, and that's when the bridge decision kicks in. And but like for the bigger bridges. And you can see them on the screen now. The typical bridges that we would use are called composite steel concrete bridges. So it's a combination of concrete and steel, basically. So the how it works is you have foundations for the bridge on either side of the water course or of the water body, and then you have a bridge abutments. Abutments are the big concrete sort of forms or blocks that hold up the bridge deck on either side, and those sit on the foundations. So they bear the most of the load then of the weight that's on the bridge. And then you have these things called girders, which are steel, and they run along the road underneath the bridge deck, and they support the bridge deck. And then if the span is wide enough, you may need to have what you call piers. Piers are those things that stick out of the water that are used to help hold up the bridge. So,
Extra support.
in extra support. So in more sensitive areas for fish, quite often they try to, where possible, do what you call a single span. Where you go all the way across without piers. So that's one option that can be used because that limits the amount of in-water work you have to do, right? Because you
Yeah.
can imagine if you're putting in a bridge pier, there are short-term impacts on fish habitat just because you've got to dig down underwater to get that pier in the water and drive it down to a certain point where it can be it's on firm enough ground to be able to support the bridge reliably. So there's a lot of situations like that. But again, with a single span bridge, which you can do, I think up to a certain span width. I'm not an expert on bridges, so I can't tell you what that is. But you'll see that quite often is the single span bridges with no piers in the water. And
Right.
what
And the
if we move to the? Sorry, Jen, go ahead.
Oh, I was just going to say, and the bridges will accommodate traffic in both directions, so they won't be
Yes,
just
good
like
point.
daily bridges or one vehicle crossing
Yeah,
at a time.
yeah, good point, Jen. Yeah, these are not single lane bridges. These are 2 lane bridges, so they would have side barrier walls as well. So why don't we have a look on the next couple of slides, starting with the Winnisk Lake crossing. These are sort of visualizations, and it's kind of hard, might be a little hard to see, but this shows before and after at the actual crossing. So they've superimposed in the after image um, what a bridge might look like over this stretch. So as you can see, it's fairly low profile. It's not a massive structure. It's fairly low structure.
And then you
Like
see
there are
some of those. Are those when you're talking about piers? So are those piers through this span?
there are so this image. Now this isn't necessarily like the final bridge design. It's just what
Hmm.
a bridge could look like there, right? So as you can see, there's a number of piers in the water on this stretch. Um, but I suppose if we'd have to talk to a bridge expert, you could go with fewer piers
Because this
across
one
this
has
span.
six.
But it has 6, yeah, 3 sets of 2, I think. Yeah, 3 sets of 2. So yeah, that's definitely a possibility. But that image is more just to sort of give community members a sense for what it would look like with a bridge in place. So it's nothing. It's not something that's you know, really jumps out. It's fairly low key, like low profile, I would say. If we can move to the
Yeah,
next slide.
it's not super high, and you can fit a boat under
No.
there
Yeah,
quite easily.
absolutely. That's right. Yep. So if we move to the next slide there, like we had, there we are. So this is Winnisquis Channel crossing. So again, this is 30 to 50 meters wide, and it shows piers here, but you could certainly go across with a single span on this. And again, fairly low, right? But like we're not talking about major shipping traffic going through here. Like there's no
Hmm.
um, oil tank super tankers or like container ships going through here, right? This isn't a major port or anything like that. So it's mainly small boats. So as long as there's more than enough clearance, it allows the bridges to be fairly low profile and not sort of stand out too much. So pretty standard looking kind of bridge that we see a lot on highways, don't we?
Hmm.
And then finally, let's go to the Mukatai River crossing. If we can bring that one up.
So
So
this
this
one's
is
a little bit higher.
It's a little bit higher, that's right, and that may have to do with how the water levels change. I'm not sure, right? Depends on again the
And the banks,
hydrology
I think, too.
and the banks. Yep, that's right. So, you know, they look at the characteristics of all these water courses and they study them and they do modeling to look at what the flows could be, you know, in the worst case scenario, and then they
Yeah, or
come up
any
with a
given
design
season,
based on
right?
that. Yeah, yeah, exactly. They have to look at all of that, right? And then figure out what should be the bridge deck elevation and then work from there, right? So this is the excuse me, the preliminary design that they came up with for this bridge. So it's a little bit certainly higher than the previous one, or at least it looks higher anyway from this perspective. But
Hmm. Yeah, it
I
looks
think
like
that's
there's a
kind of
bank that was built up a little bit.
yes, on the left side there. Yeah, yeah.
Hmm.
Yeah, I mean, these are always interesting, these visualizations, and we've got some other visualization things that we'll show you in some later shows that we've come up with, which are kind of neat as well too. Some tools. So let's move on to the next slide, which is culverts, where we're going to talk a bit about culverts. So when we talk about culverts, there's really three types. There's the open bottom steel arch culvert, and the open bottom one. Um, the reason why it's open bottom is to allow they're typically used in areas where there's fairly significant fish habitat, so you
Hmm.
want to preserve that. So you don't want to drop a pipe on top of it. You basically want to arch this culvert over, and then you have basically concrete walls on either side that the arch culvert sits on, and you can see that in the image on the far left there. There are these walls that run along the side, and then the culvert sits on top. So the weight's borne by the concrete walls on either side of the culvert. And then you have the steel arch culvert as well, um, which is sort of another variation of that. And then you have the corrugated steel pipe, which is an actual pipe that's basically put in place, and the road's built right on top of it. And as you can see around all these culverts, you notice there's stone around them, and that stone is what you call riprap stone. So it's sort of medium-sized stone, and it's used to sort of protect the openings to the culverts because they're also susceptible to erosion. So if you didn't put that rock around the pipe like that, you'd get erosion around the pipe, and then the pipe would fail. And you see examples. You've probably seen them in your travels where if a culvert pipe hasn't been protected properly, over time it just starts to, all the earth that was keeping it in place starts to disappear through erosion, and the pipe starts failing and moving around, and then it stops. Then it fills up with sediment, and then it doesn't perform a role anymore because it's not moving water through, right, Jen?
Hmm. And in our
So
scaffolds on
next,
some of those corrugated steel pipes,
yes, yeah, that's right.
just in case,
Next,
because
why
they
don't we?
like to get in there.
They do, yes, yeah, that's right. Why don't we go to the next slide, which talks a little bit about muskeg. So I'll just remind everyone that muskeg is the muskeg areas are areas sort of, I guess, what would you call them, Jen? Squishy areas, right? Spongy, squishy areas. So what they are is basically thick mats of floating vegetation. So it may look like it's dry, but when you walk on it, you sink in it
Yeah.
to a degree. Sometimes pretty far. You can sink pretty far in them.
Yeah,
And
sometimes up to your hips.
yeah, yeah, yeah. And so what is underneath the muskeg is what you call peat, which is decaying organic matter. And so we've done studies for Webequie Supply Road through the muskeg, and we've identified that the peat thickness ranges from 1 to 5 meters thick. And so this presents challenges. As you can imagine, trying to build a road through this presents a lot of challenges. And the thicker
Hmm.
the peat is, the more complicated it is to build on. So building roads is a lot different, and you'll see in other presentations when we talk about muskeg, building roads in muskeg, it's a completely different animal. If we go to the next slide, this will just give you an idea of building roads in muskeg. You can see this is all muskeg area. So on the left and right sides of the open water, you've got, it looks like land, but it's really muskeg. So it's squishy vegetation. The water's moving very slowly through it. But you've got to make sure you don't cut that water off. Otherwise, it'll start accumulating on one side of the road because the water is flowing. You just don't notice it. So you've got to provide outlets for the water when you build roads in muskeg. So, the water crossings here, if you look at this, this road is built with uh, sort of larger pieces of rock, and
Hmm.
using larger pieces of rock as the road base allows the water to still flow through it, right? It moves slowly, but at least it has big spaces between the rocks to flow through. But where you actually have open water, like you see in the middle of this image, that you still have to make sure the water flows through there. So you'll see they've used a double culvert um, in this case because they're trying to move a lot of water through. They don't want the water to build up on one side of the road. So
That's
water
right, because you're not
course,
damming it.
you're not damming it. That's right. You got to let it behave like it normally behaves, right? Otherwise, you're going to get problems. Water backs up, it washes out. It's very expensive to repair. Roads shut down, causes all kinds of problems because people can't people can't people can't get to their communities, right? So presents all kinds of problems. And wow, we're done. It looks like we're done for the day, eh, Jen? Look at this. I'll just remind everyone that to get in touch with us, they
For the
can
whole day.
contact us. Well, well, we got more work to do, as you and I know. We got radio to do, Jen.
We got
So
radio later today.
we got radio later today. So thank you, Jen, for joining me on this. And that wraps up today's discussion of water crossings. And we hope this was helpful. And we hope you come back and join us again next week at the same time when we're gonna we're going to talk about using Indigenous knowledge in the environmental and impact assessment. So that'll be a really great topic. That's an area that's changing very quickly. You're seeing Indigenous knowledge appear a lot more and in a lot more places in environmental assessment or an impact assessment. So don't forget to keep in touch with our project team members via the contact information available on our website and on your screen right now. Our website is supplyroad.ca. Miigwech, and we will talk to you again next week.
All right. Chimigwech, Bamapi.